Yes, sir, just a second, I'm just solving.
Okay. So I'm going to solve this question number 9 along with you, beta. So it's given that px square plus qv square equals to r. Can you tell me the steps, beta?
Sir, first we will take out x where v is 0. So we can put v 0 and we get x is equals to plus minus root of r by p.
Is that right? Plus minus.
Yes, sir.
So if I were to quickly draw it, the particle is moving between these two positions. So this is when v is equals to 0, this will be at
Sir, I'm getting answer as A.
you're getting an answer as E. Just to understand how you did that, so you from here, once you had the expression for x, or rather you had the expression for v, not the x.
Sir, we can have the expression of v as root of r minus px square upon q, and
Okay.
we can write v as dx by dt, and then we can integrate.
Okay. Now, quick question is, will you take this as plus or minus square root of r minus px square? What will you take there, बेटा? क्या लेंगे आप वहाँ पे ना? Any guesses?
Sir, I'm not sure.
Okay. Beta, if you take plus, what does it mean? That the particle is moving in the plus x direction?
Yes, sir.
And the particle will go from minus square root of r by p to plus square root r by p. If you take v is equals to minus square root of r minus px square by q, then you will take your limits when you integrate this. Right? After all, you're going to be integrating this from 0 to t and from some initial value of x to some final value, right? So if you take plus, then your limits will be from minus square root of r by p to plus square root r by p. If you take that as minus, then the limits will switch, right? Because minus would mean actually it's going from square root of r by p to minus square root of r by p. Does that make sense?
Yes, sir.
Okay. You will still get the same result. You will still get the same result, beta. And your answer, you said, is? What is the answer? A.
Yes, sir.
Okay. Okay. Let's go ahead and do another problem. So we're going to look at number 28. Let's take attempt this one. Let's solve this one, beta. So the t is given to be kv square, p is the velocity. So will the acceleration of the particle be constant, root 3 meter per second square? Will this be correct?
No, sir.
No. Okay. Okay. Okay, बेटा?
Yes, sir.
बेटा एक सेकंड होल्ड रखें. Yes. So what is the acceleration, beta? It will be square root of t by k is v. So if you were to differentiate, so acceleration is instantaneous acceleration, right? This is a instantaneous. This will be 1 by square root k t. Is that right, beta?
Yes, sir.
Okay. So a is 1 by 2 square root of kt. Now let's talk about number B, average acceleration of the particle. Average acceleration in this duration 0 to 5 seconds, first 5 seconds. So what is the average acceleration definition, beta?
Sir, v final minus v initial from the time taken. Sir, we can find out the k by substituting values of 10 seconds and 10 meters, the point that we are given. So we get k as equals to 1 by 10.
So k is 1 by 10. Wonderful.
Yes, sir. Sir, C option is, I'm getting the C option is correct. The average acceleration is root 2.
Okay, for the interval of the first 5 seconds is coming out B. So this is 5.
Sir, root less than root 3.
Okay, so what will the final velocity, what is the velocity at this point?
Sir, 5 root 2.
5 by 10 or 5 into 10, 50, correct?
Yes, sir.
Okay, so 50 will means 10 by root 2. So 10 by root 2, or I can say 5 root 2.
Yes, sir.
5 root 2 minus 0 divided by 5. So we get this as root 2. So it is less than root 3 meter per second square. That is correct. So C is correct. Okay, since it's a, I think this is a multiple choice question. There's a multiple choice question. Just check the D as well.
Sir, none of them, it should be
None of them
single
are.
option only.
Okay, let's do one more problem before we go ahead with the. Let's do number 32. Let's do number 32, beta.
Sir, what exactly the definition of velocity gradient?
Velocity gradient will be beta, in this case, dv by dx. dv by dx. Position. Now let's call it dv by ds so that there is no confusion with the axis of the graph that they're talking about. So if this is the x and this is y, then what is the relation between x and y? Under constant acceleration. Acceleration is constant.
And so a xy is equals to constant.
Wonderful. And how you did that is you took acceleration as dv by dt.
So acceleration is equals to v dv by dx.
Right? That's how you took it. You divided the two, you get it a by v, dv by ds. They're calling this as y, this is x, so you get a by x is equals to y. A is constant because it's a constant acceleration scenario. So constant is equals to so on. Right, madam?
Yes, sir.
Okay, good. Since the other student has not joined us, so what we'll do is better, how about we take this for a practice run, right? Because you have gone through this chapter before. So once the other student join in, we'll again go through the different question types sequentially. But for now, for today, what we can do is we can just go through all the different kinds of kinematics questions. So will that be okay if we do some practice run?
Yes, sir.
Okay. Let's start with question number 3, Vida. Okay, so we are so for those on the YouTube, we are switching to solving questions, kinematics questions, and these are, so today we are not going to follow the sequential way of approaching, of going through all the different types of questions. So today is a practice run. So the students we have, they have gone through this chapter before, so this is a trial run. These questions are of the level of JEE Advanced. So let's see. So let's see how everybody does it. So I'm gonna switch back to the live class. But is that okay if I solve the question along with you?
Sir, can I just verify if I'm going in the right direction?
Okay.
So both the shots are fired with the same velocity. So we can take out the u, the velocity with which it was fired from the second one, which was fired from the bottom of the cliff, and we can use it to take out the range or edge for the one which was shot from above the cliff.
Okay, so I think what you're saying is to find out the velocity, okay, this is I'm trying to figure out what you are trying to say. So you're saying, okay, we don't know the velocity, but we know v cos 30 into the time t, because both travel in the time t, both travel the same horizontal distance. So let us say it one more time. What's the point again?
So, sir, we can find out the time in which, so basically, we can, in form of u, we can take out the time in which the second body, which is fired from the bottom, travels its range. To use it to find out we get the time in which the other body that was fired from the top of the cliff travels the whole distance.
Okay, so let's see, what are we given, beta? So are we given their velocities? No. Will v1 be equals to v2? Not really, right? Why? Because if they strike the object simultaneously at the same point, which means that in the same time duration they have covered this range of 30 square root 3 meters, which means v1 cos 30 times t is equals to v2 cos 60 times t is equals to distance a, which implies that v1 cannot be equals to v2 if you look at this part. Right, Peter?
Yes, sir.
Okay. So what is the other two equations? We only have two equations to work with, right? So one is in the, or I should say two groups of equations. One is for the horizontal direction where there is no acceleration, and then two independent equations for the vertical direction. Right, so v is equals to u plus at and s is equals to ut plus half at squared. We can try and use those in the vertical direction. And so let's see, beta, if that can be how you're going to use it, right? So let's say for this one, for the second particle, beta, how about I let you do it on your own, and I'll scribble something on my own at this end. Okay, beta?
Sure, sir.
So but the way I have written my equations, I have 4 equations in 4 unknowns, which means I should be able to solve them and find out the desired unknown. Yes, beta. What is the time that you're getting?
I got stuck in the equations.
Okay, so let's quickly check back our equations. So the first relation is, as you rightly pointed out, so v1 cos 30 times t, which is the time of flight for the two particles, is equals to v2 cos 60 into t. So that gives us the relation between v1 and v2. Yes? Right?
Yes, sir.
Okay. Now from the second one, the v2 cos 60 into t is equals to a, and your other relation, this equation for the particle 2 in the y direction, 2v2 sine 60 by g equals to t. So from equation 2 and this equation, if you divide number 3, equation 3, by equation 2, so what do we get? So we'll get 2 tan 60, and I'm going to take, by the way, just for the ease, I'm going to take g on this side, so we'll write this as gt. Okay, beta? Now we'll divide the two equations. Divide 3 by 2. So v2 will cancel out. So 2 tan 60. 2 tan 60 by t is equals to gt by a. Oh, I'm missing the g here. That's why. gt by a. A is given to be 30 root 3. 30 root 3. And tan 60 is simply root 3, right? Sine 60 by cos 60, sine 60 root 3 by 2, cos 60 is 1 by 2. So t square, sorry, not multiplied here, it is going to be divided, right? So it will be this divided by 10. So it'll be, t square will be 18, right? So t will be 3 root 2.
Sir, is it 60 meters?
Are you getting this as 60 meters?
Yes, sir.
Okay. Take it, beta. So let me just quickly, you can correct me, beta. So t is 3 root 2 seconds. So if time is this much, then I think we can figure out the rest. So what is V1 then? Because for the equation 4 we will need that. So let me see. So V1 from equation V1 cos 30 times t equals to a, will get V1. Cos 30 is how much? Cos 30 is simply root 3 by 2. Time t is 3 root 2. This is equals to a, which is 30 root 3. So V1 is 10 root 2. So if V1 is 10 root 2, then from equation 4, your height h, this is what we are trying to find. So h is half gt square, half gt square. That means if I take g as 10, so there will be 5 into t square is 18, minus v1, v1 is 10 root 2, sine 30 is 1 by 2, into time t, which is 3 root 2. Okay, so I get 90 minus 30, which is 60 meters. So I'm getting the same answer as you. Let's move to the next one.
Answer question number 4.
Question number 4. Hello, yes, is this Chavi? Yes, ma'am, yes. So Chavi had not joined in, so I was calling to check if everything was okay there. No worries. Yeah, yeah, absolutely fine, absolutely fine. And I can understand, I can understand. No worries, no worries. Sure, sure, sure. No worries. Okay. Yes, Peter?
Sir, I don't remember the equation of trajectory.
Let's quickly find that, but even if you don't remember, that's fine. So where do we get it? Only two equations, right? So V is equals to, let me just, so three equations for the projectile motion, two in the vertical direction, one in the horizontal direction. So for the vertical direction, what do we have? Now, to be honest, we are not really interested in the in that part. So let's forget about the v equals to u plus et equation in the vertical direction. So we will just focus ourselves or interest ourselves with the other one, which is y is equals to v, and let's say this angle, launch angle was theta. So u sine theta into t minus half gt squared. And in the horizontal direction there is no acceleration, so the position of the displacement is u cos theta into t. So from here t is equals to x by u cos 30. So t is equals to x by u cos 30. If you put that in there, right, so now you're removing the variable t, so all you'll be left is relation between x and y along with the initial launch conditions, right? So initial launch variables u and theta. So what do you get? So y is equals to x tan theta minus half g t squared. That means x squared by u squared cos squared theta. Okay?
Yes.
Right, Beta? So this is the equation. Here theta is not mentioned. We are given the the coordinates of the point from where we want the projectile to hit, and we are given u. So let's just do this together. So if I were to put in y as beta, so we'll get beta is equals to x is alpha tangent theta minus g by 2 x square divided by u square, which is 2g alpha cos square theta. Right, beta? So I'm going to cancel out, and x is alpha square. X is alpha, so this the numerator we get alpha square. So I'm going to cancel out g from there. I'm going to cancel out 1 alpha. So what do we have after that? So we get, I'm going to take alpha out. Take alpha out. So what do we get? So we get alpha tan theta minus, what do we get here? 1 by 2 cos squared or secant square theta. Right, beta? Secant square theta?
Yes, sir.
Which we can write as 1 plus tan square theta.
Yes, sir.
Okay, okay. So let's see if we can further solve it from here. How would we proceed, beta?
Sir, we have two variables.
Now we have one equation in theta, right? So we have only one equation in theta, alpha and beta. So so beta by alpha is equals to, so tangent theta minus 1 by 2 secant square theta. I'm going to write this as 1 plus tan square theta. Now let's write it here. So we get beta by alpha plus half, or rather let me do this. So I'm going to say 2 beta by alpha is equals to, the equation then becomes negative tangent square theta minus 2 tan theta plus 1. Right, Vidam?
Yes.
So this is interesting now. So 2 beta by alpha. So we will have so the right hand side is, so we can, so tan square theta minus 2 tan theta plus 1, that is equals to a negative number, right? Assuming that alpha and beta are the positive coordinates. Okay. Have we made any mistake here? I don't think so, right? So far we have not made any mistake. In fact, let me bring this over. So let's do it this way. So I'm gonna bring this to the left hand side. So what do we get? So tangent square theta minus 2 tan theta plus 1 plus 2 beta by alpha. This is equals to 0. Okay, so you have a quadratic equation in tan theta, right? So for it to have real roots, for for tan theta to have real roots, what is the condition? That its determinant, that is square root of b square minus 4ac, right? So that should be greater than 0, no? So b square minus 4ac should be greater than 0, right, beta?
Yes, sir.
Okay, so let's use that, and can you quickly tell me what will that give us? Chavi beta, we are solving, we are just kind of having fun with some JEE advanced level practice questions. So question number 4 here. And I'm assuming, Chavi, that you have already been through the projectile questions in the classes, correct?
Yes, sir. Yeah, I've done the projectile question in class.
Okay, okay. So by the way, as a word of caution, do not feel discouraged if you struggle solving these questions right now, because they are, yeah, they are good questions. They are definitely on the better end. Just read through it and then I'll explain how we approached it. You can just go through the question and then we'll jump back to our question types. Ruchika, do we have an answer?
No, sir.
So b square would be 4 minus 4ac. So 4, a is 1, c is 1 plus 2 beta by alpha. This should be greater than 0. Something is wrong here. B square minus 4ac. Have we goofed up on any of the equation? Yes, we have. Can you see that here is a factor of 4, not 2 in this equation?
Yes, sir.
Okay, so if you were to carry that around, so what will we get? So we'll get 1 by 4 here. What do we get here? 4, and this will be 4. So what is the equation then? So this becomes 4 beta alpha and minus 2 tan theta. Instead of minus 2 tan theta, we'll have minus 4 tan theta. Correct, no? Yes. Now, what will it become? This will become 16. That's the equation we have now. Let me just double check if we have made any mistake here. It doesn't look like it. I think we are okay here now. Okay, so what do we get? So we get this. So that means 3. So I'm just going to write it here. So 3 minus 2 beta by, or 6 beta by, no sorry, 2 beta by alpha is,
So यहाँ पे भी 4 बीटा बाय अल्फा नहीं होएगा?
यहाँ पर beta, yes, you're right, actually this is going to be 4 beta, yes, 4 beta by alpha, yep, that is correct. Sorry, I sometimes the mistake.
I'm getting 3 alpha greater than 4 beta.
There we go. So the option A is correct. This way, Chavi, the way we have approached the question, let's first understand the question. The question was, a projectile has been thrown with some initial velocity that is given to be square root 2g alpha. What is alpha? It is some constant. And they are saying if this projectile were to pass through a certain point, whose coordinates are alpha and beta, then what is the condition? Then the condition when it is impossible to hit the target. So impossible to hit the target means actually 3 alpha should be less than 4 beta for it to have, should not be able to hit. That means it should not have real roots, right? Correct, Namita? So 3 alpha should be less than this thing, 4 beta.
So, but I did not understand how did you like make an equation form of it?
Yes, Vita, let me just, give me a quick second. Let me just take this one. Hi, Jaskaran. Good evening, बेटा. कैसा रहा आपका एग्जाम? अच्छा, आपका एग्जाम कब है? 28. Yes. अच्छा बेटा. ये हाँ ठीक है बेटा. तो let me finish the class and after that in another maybe 45 minutes and then I'll call you. Already बेटा. Yeah. Let's keep it at 6:30. 6:30. Already beटा. If you allow me, then 6:30 we'll exchange notes. Whatever needs to be addressed, we'll address that, beta. Yes? Alrighty, beta. You take care. Not to worry. Not to worry. Okay, bye. Yes, beta. So shall I explain how we did it, Chavi? How we got the equation?
Yes, sir.
Okay. So the equation of trajectory, in case you forget, you know how to get the equation of trajectory. So always go back to the fundamentals. So there are two governing equations for the vertical direction, which is v is equals to u minus gt. Where is what is v? V is the velocity, the vertical component of the velocity. What is u? U is actually the vertical component of the initial velocity. So it will be u sine theta. So that equation and the other equation is y is equals to u sine theta t minus half gt square. And then in the horizontal direction, you have one more equation, that is x is equals to u cos theta into t. Right, beta? So from those two equations, you can quickly determine, you can eliminate t and get your equation of trajectory. You only require two equations. Which ones? Y is equals to u sine theta t minus half gt square. And let me just change the color so that you guys can follow what I'm saying. So you can use these two equations to get your equation of trajectory. If you remember it, well and fine. But remember, this is a long race, right? So many people bank on memory part, and you will hear a lot of people say, just memorize the formulas, memorize this, memorize that. That's not how the brain really works. It's very difficult to memorize things. At least for most. Some people may be very good at memorizing things, but that's they follow different techniques. But in any case, you have your equation of trajectory, right? This is your equation of trajectory. Now, alpha and beta, those points need to fall on this equation of trajectory. So if you were to substitute y with beta and x with alpha, that should still satisfy this equation of trajectory. So if you do that, If you do that, then this is what you will get, right? So your beta comes out to be alpha tangent theta minus half 1 by 4 secant square theta. Okay, and remember we have substituted u square as 2g alpha because u is given to be 2g alpha. Now from this point, now this is a simple mathematical trickery now. So we have converted secant square theta into tan square theta. Recall that 1 plus tan square theta is secant square theta, right? So 1 plus tan square theta. Tan square theta is sin square theta by cos square theta. So that will become, if you take cos square theta plus sin square theta by cos square theta, that means 1 by cos square or 1 by or secant square theta. In any case, so if you do that, then you get a quadratic equation in tangent theta. What is theta again? Theta is the angle of projection. Now, so you have a quadratic equation. What we are saying is condition when it is impossible to hit the target. Impossible to hit the target. Now, what that means is that we need to have the condition, we need to determine the beta and alpha, the relation between the two, such that this equation does not have any real roots. If there are no real roots, that means there is no value of theta between 0 and pi by 2 for which it can hit the target, or it can go through that coordinate alpha beta, right? And what is the condition for it to have non-real roots? The square root of b square minus 4ac. b square minus 4ac, if that is less than 0, then tan theta will not have real roots and will be impossible to hit the target. And that's what we have done here, Vida. So we need to reverse the sign because we're talking about impossible. This should be less than 0 here. Okay? Did you follow the logic? Shall Beta, I need some confirmation. Beta, were you able to follow the logic?
Yes, I was just going through it once. Yes, I got it.
Okay. So we solved roughly about 5 odd questions now. So this video, you can refer to that, this video maybe after the class, and you'll be able to see. So these fun questions, Beta. They're definitely going to test us. Now let's go back to our session. And the whole idea is those are practice questions where once you are battle hardened, that means we have done your SC Verma, you have done your all the previous year questions for JEE Advanced, NT JEE Mains, and for further practice down the road, and obviously you will be doing the Centum and Akash or FitG, so you guys will be doing all those. But after that, you can take these questions as a challenge. Okay, beta? Okay, so today we're gonna jump into number 10. We're gonna get into the basics of relative velocity. So let's get started. Okay. So before I go any further, Chavi, let's just have a chat. Let's just see what we understand by relative velocity, and then of course we will jump into a bit more finesse. So whoever wants to start, whatever you guys recall from your previous classes, or the basic understanding that you have. How do you define relative velocity? So let's talk about the one-dimensional motion, and then we'll talk about the two-dimensional motion. Ruchika beta?
Yes, sir. Sir, relative velocity can be understood as if two particles are moving with different velocities, and if one is made, or if the observer is sitting on one of the particles, and then it is made to observe the motion of the other particles, so the velocity observed will be the relative velocity.
ठीक बेटा, we'll take a look at different examples. We'll try and get deeper into it. Chavi, whatever comes to mind, beta, whatever comes to mind is okay. No right or wrong.
What I understand is that like even when you're measuring like velocity in general cases, we take a point of reference, right? So what I think of this is like when there are two or more objects moving, we take one of the moving objects as like a point of reference, and then we calculate the velocity, distance, or acceleration based on that object, like of the other object based on the other object. Like, I don't know if that makes sense.
Okay. Now, this blog, I'm going to be sending you guys a copy of this, but you should go through it in detail, right? You should go through the blog in detail. So let's just kind of go through it, and this is fairly structured. So I'm just going to follow the outline here, and then on the way we will try and have a discussion on different scenarios. Okay. So relative motion typically refers to the relative position of one object as measured from the other object, or relative velocity of one object measured with respect to the other object. Okay. System seems to be very slow. This may be because it's streaming as well as it's being shared on the Google Meet. That's fine. We'll have to figure some solution out there. Okay, so now it says, so let's start with the relative position, and then we will talk about the relative velocity. And let's see, in fact, there's a lot of interesting stuff in here. So we're going to talk about, let me just kind of read through the outline. So we'll discuss the relative velocity. After the relative position, we'll discuss the relative velocity of respect to another in one dimension, followed by relative velocity in two dimensions, wherein we will review the Rain Man problems, the swimmer in river problem, and the projectile problem. And the projectile problem is wherein the projectile is projected from a moving platform at some relative velocity and projection angle, and will need to determine the initial velocity and projection angle with respect to the ground. Anyway, so don't worry about the technicality there. It says, note that in all these three types of problems, we are either interested in establishing the relative velocity vector in two dimensions or the velocity vector with respect to the ground. Okay. So once again, typically we're interested in two things, either the relative velocity vector, or if you know the relative velocity vector, then the velocity vector of one of these particles with respect to the ground. Okay. And then we will look at some interesting problems wherein we will try and determine the minimum distance between the two particles as they, for example, as they are moving in the two dimensions along straight lines. For example, let's say this particle is moving this way and this particle is moving this way. Obviously, the chances of them hitting each other, meeting somewhere at this point, it depends on their velocities or their relative velocity. But if they're not going to hit each other, then we want to find out the minimum distance. So when the particle reaches, this particle reaches here, then this one perhaps is here, and they will continue. So we want to find out the minimum distance. Okay. Or we will determine the time to collision for two objects moving in two dimensions. In any case, there is quite a bit of different scenarios. So if we do this, it will definitely help our understanding of the relative motion. Okay. So starting with the relative position. So for two particles A and B, moving along one dimension, say in the vertical direction, the relative position of A with respect to B at some time t would simply be YA minus YB. Once again, vertical direction है draw कर लेते हैं. Let's say this is the ground. At some time t, when we take a photograph, let's say A is here, B is here. Let's say our coordinate system is here. The origin is here, and this is our y direction. So the y coordinate of B is YB, y coordinate of A is YA. Then the relative position is YA, y relative of A with respect to B is equals to YA minus YB. That means this is the position that B sees it, and which makes sense, no? B says, oh, actually A is only this far ahead, no? This far above me. Correct, no? By the way, if their positions were reversed, then B will report, so let's say, this is B, this is A. Then what will B say? B will say that A is, let's say this distance is D. A is D meters below me, right? Or if B is well educated and has a good understanding of how people report, then he will say I choose my y coordinate in the vertically upward direction, and the position of A with respect to me is minus D meters. Yes, correct, no? Okay. Now let's define the relative position of A with respect to B in 2 or 3 dimensions. Okay, so how can we do that? So let me see if I can. So let's say now I'm gonna draw X and Y. These are, let's say X is the horizontal, Y is the vertical, right? And if you wanna make it interesting, you can add Z direction as well, where X might be along, say, pointed along east, Y might be pointed along the north, and Z might be pointed along the vertically upward direction, right? But for us, let's look at the 2-dimensional situation. So let's say there are 2 particles which are moving in a plane, right? Moving in a plane. And let's say the particle A is here, particle B is here. Okay. Now, first thing you need to recognize is we need to be able to tell the position of A and B with respect to some coordinate system. So here, when I drew my axis, I've already chosen my coordinate system and my origin, right? I have chosen the direction along which my X direction is, and where my Y direction is, and where my origin is. So as per this coordinate system, so if you were to report where is this particle at that time when we took this photograph, well, this is the position vector. What is the position vector? Position vector, as the name tells us, is a vector which tells the position of that particle, right? Particle A with respect to the origin. In other words, the tail of the position vector is at the origin O and the head is at A. Okay. But how comfortable are we with vectors, by the way? How comfortable are we with vectors?
So quite comfortable actually.
Okay. Ruchika Beta, you're all.
Yes.
Okay, I'll assume you guys are comfortable. Okay, moving on. So now, similarly, for the point B, the position vector is RB. Like this. This is RB. Yes, Peraji? No issues there as well?
Yes, sir.
Okay. Now we're talking about the position of A with respect to B. So B will say, actually A is the position vector is this with respect to B, with tail at B and head at A, right? This is the position of A with respect to B. Correct, no? Now, since you guys are familiar to some extent with the vectors, so we'll use the triangle law, right? Triangle law of vectors. So these three vectors form a triangle, right? If they were everybody's head was on somebody else's tail, right? So then their sum would be 0. In other words, we can also, for this given scenario, we can write RAB as RA minus RB. Is this part clear? Do we have any questions on this one? No confusion now? Fairly simple, straightforward?
Yes, sir.
Okay, so position vector of or the position of A with respect to B, right? So now it means that the tail of that vector is at B. We can follow the coordinate system and whatnot, but we are trying to describe that vector RAB. So RAB can be written in terms of the position vectors RA and RB as RA minus RB. And if you were to write RA in the unit vector notation, where RA can be written as xi cap plus yaj cap plus za k cap, and similarly for RB, then your relative position, you xa minus xbi cap plus ya minus ybi j cap plus the za minus zb k cap. Okay, it says now let's solve two problems that will challenge our problem solving skills. Okay, so let's take a look at some of the problems here. Okay, please go ahead and solve this question. Two stones are, I'm just going to read through it with you guys and then you guys can take it up and try and solve it. Two stones are thrown up simultaneously from the edge of a cliff, 240 meters high, with initial speed of 10 meter per second and 40 meter per second respectively. Plot the graph representing the time variation of relative position of the second stone with respect to the first. Second stone is the one with 40 meter per second speed upwards. And then it says assume the stones do not rebound after hitting the ground and neglect the air resistance. Neglect the air resistance. How about I solve this question with you guys? Would you want to take an attempt at it or would you like me to solve it?
So we'd like to take a time.
Okay, go ahead. For those who are going to be watching this video on YouTube, so you will notice that we do solve quite a few questions during the class, and that is very intentional. And what is the intent? We need to start developing problem solving skills. It's not enough to just learn the concepts. So the concepts are fairly simple if you think about it, right? So even if you talk about relative position or relative velocity, or what we learned about we had some initial discussion about the projectile motion today, or the equations for one-dimensional motion, kinematic equations. So they're fairly simple and straightforward, right? So trick is learning the ability to apply these equations quickly to different scenarios, right? So that is the key challenge here, and that is the skill that IIT is looking for, or that the NTA is looking for, whether students have the problem solving skills. And why is that important? That is important because um, once you guys do engineering and you guys pursue um, any career in engineering or other areas as well, um, in real life you will be expected to be solving questions, solving real life problems, not these kind of questions, but real life problems with the knowledge at hand, right? With whatever knowledge you possess, you will be expected to solve, and that will determine your success in your careers. So this is a good start from that standpoint. Anyway, so let's come back to the students in the class. So they are not able to hear what I'm saying at the moment, uh, but they are continuously uh, solving the problems on the spot. In other words, so when I'm teaching certain concept, it's not just that I teach them concepts and they take notes and then they move on, and then they go home and they try and solve problems. Why are we solving them in the class? Um, because unless we struggle with the problems together, depending on how much what's going on in their day-to-day routine, they may or may not get the chance to practice problems. So that's why I personally put in a lot of focus or attention to students solving problems during the class. And interestingly, there is plenty of time that the teachers have in the class, and um, I actually encourage all the teachers as well, whoever I can speak to say that students should be solving a lot of questions during the class itself to build the skill, and not just the some sample problems, right? And that's what the concept of the question types. We want students to understand different scenarios, different scenarios they can expect to see, right? So that will hopefully significantly improve their problem solving skills. In any case, please do take your time and try and solve this problem, and let me jump back into the class and see how the students are doing there. Yes, beta, Chavi, Ruchika. Is it okay if I start to solve the question with you guys?
Sure, sir. Sir, I was getting a graph. First was it was linearly increasing, and then it was a parabola.
Okay.
Sir, and the maximum relative position was 240 meters.
Okay. So Chavi beta, which one will hit the ground first? Will it be the 10 meter per second one or the 40 meter per second one? Which stone will hit the ground first? Okay. So beta, stone A will hit the ground first. There are different ways you can think about that. You can use the S is equals to UT minus half GT square equation. You can think about which one reaches their topmost point first, right? So that also depends on the initial velocity. Obviously, A with the 10 meter per second will reach the topmost point first and will start to fall from that point in the downward direction. B with the speed of 40 meters per second will climb higher, will take more time to reach to the highest point, and then it will start to fall. How much time does it take to reach the highest point? Well, we can use V is equals to U minus GT. At the highest point, V is 0, so time is U by G. Right? So more the U, more the time it will take to reach the highest point. After that, it becomes a free fall from that point. And it's pretty obvious that A will reach the ground first. So we are talking about the relative position. So when both the stones A and B, when both the stones A and B are in motion, then that's one scenario, right? So there we have to figure out the y coordinate of A and y coordinate of B, and then we'll say YB minus YA, right? YB minus YA. Now the second scenario would be when A has hit the ground, A has reached the ground and it has not bounced back, so it is not moving any further. So now the distance between A and B would be closing fairly quickly, right? At what rate, at what will be the relation, we'll derive that. Chavi beta, I'm sure you have already made good progress in how you are approaching it. So let me write the equations and you can match your approach and see where you were at. Is that okay, beta? Beta, you're on mute. You might give me some confirmation.
Yes, sir. That's fine.
Okay. Okay. So first scenario, both the particles are in flight. So the first is both the particles are in flight. Right? Then what will be the y coordinate for A? Now, if I put my origin at the topmost point or at the bottommost point, either way is fine, right? You can define it either way. Let's say the origin is at the topmost point, O. So if you keep your origin at the top of the cliff, then your y coordinate for A will simply be UA, which is 10 t minus half gt square. And what is YB? YB will be 40t minus half gt square. So if you would try and find the position of B with respect to A, YB minus YA, right? So in general, if you want to find out the relative position of, let's say Chavi, your relative position with respect to Ruchika's, there'll be your position minus the position of Ruchika, right? So just follow that logic. So YB minus YA, what will that give us? That'll give us 30t. That means the distance between the two, the relative position is, see, the distance is continuously growing between the two, 30t. Right? So as the time increases, it increases linearly. This is YB minus YA. Yes, Peter? It increases. We know that after both the stones have landed here, it will come back to 0. We can tell that much part. Right? Now, so for how long does it follow this? Well, it follows this relation till A hits the ground. So question is, when does A hit the ground? Let's quickly find that time period. So let's call this time T1. So what is that T1? Well, we're going to use this relation. So when YA becomes minus 240, that will be a 10 T1 minus 10 by 2 t1 square. Okay, so what do we get? So I'm gonna just do a quick, hopefully I'm not gonna make any errors in here. So I'm gonna bring t1 square to this side, and I'm gonna bring minus 2t1 on the left hand side, and I'm gonna keep so this will be minus 48 equals to 0. Hope I have not made any mistake here. So now let's go ahead and solve this one. So what do we get? So we get t1 is equals to minus b, that is 2 plus minus square root of b square, that is 4, minus 4c, that is plus 4 into 48, divided by 2. What do we get? 2 plus minus, if I take 4 out, that is 2. I'll be left with 49, that will be 7. So 2 into 7, so that will be 14 divided by 2. Now t1 should not be negative, right? t1 should not be negative. That will become meaningless, right? They'll be meaningless. That means what it will mean is even before you actually launched it, it hit it 14 seconds or whatever before, prior to that, or 6 seconds prior to that, right? So that is not the, that is a invalid solution, unacceptable solution. So what is the acceptable solution? 16 by 2, that is 8 seconds. This is 8 seconds. And what is that maximum? Well, 30 into 8, so that is 240 meters. So this is 240 meters. Now let's see what happens afterwards. Once we have reached this, so let's see. So we wanna, after that, how do the equations change? Okay. So after that point, YA, so I'm still gonna keep my origin at the top of the cliff. So after 8 seconds, YA freezes. It does not change anymore. What is YA? Minus 240 meters. So it remains still there. Okay, good. Now, what happens to YB? Well, YB is still moving ahead, right? So YB is still governed by this. So your YB is still following this equation. And once again, what is time t? Time t is the time duration measured from the point of your the start, right? So when we when we fired the two particles, right? When we launched the two particles. So what will be YB minus YA now? So YB minus YA will be 40t minus half GT square plus 240 plus 240. Okay? Does it make sense? And now what is this equation? This is the equation, this is the parabola equation. So I'm going to take, so let's quickly write it down. So if I take 10 out, what do we get? So 24 minus 40, and I'm going to take 5 out rather. So what do we get? This will become 48. The minus 40, same equation will get, no? Why are we getting, or maybe not the same equation? That's fine. So minus 80 minus 80 minus t square. Please check the equation for me. So I've taken g by 2 out. So if I take g by 2 out, so I've taken 10 out, or rather I'm taking 5 out. So that's what we'll get. Correct, no, beta? And I can write this equation as, how can I write this equation? Can I write this as, what will be What will this be, beta? Can we write this as t minus 8 something into t minus 8? So we can write this as what is t minus 8 square? This is t square plus 64 minus 16t. Where are we going wrong with this one? So 48 minus 8t minus t square. I have not done any mistake there. So this actually we could have taken this out there. This is 10. In fact, how about this? Let's not do it this way. Let's change our approach. So we can write this relative position yb minus ya, which is simply y. Let's just call this y, because that's what we are plotting, right? This is y. So I can write this as y minus 240 is equals to five t that's not t minus 8. This is right, 40t minus half gt square, 5t into t minus 8. Now what I'm looking to do is I want to be going off here. So Chika beta, when you wrote down your equation, was the same equation that you got here? 40t minus half gt square plus 240? Is that what you had?
Yes.
Okay. And from here, there is nothing. So I'm looking for a rather beautiful solution out there, the beautiful form, parabolic form. And where am I struggling here? Where are we struggling? If you want to write this as t minus 8 square, we cannot do that, right? This is 5t square minus 40t, or rather I should say 8 minus t. There's a minus sign error. So 40t minus 5t square. So 5. So 8t minus t square. So I can write this as okay, so we can write this as t minus 4 square so 16 minus 16 plus 6, so 16 minus t minus 4 square, something along these lines. Will that be right? Wow, I wish I had a prettier solution here. Let's just quickly see the solution that we have written down earlier. Let's quickly go and check that. Ah, we have not written anything here. That's fine. But anyway, this is how it will look like, the parabolic equation, right? And I'll tell you later on where I got stuck. I was looking for t minus 8 something squared, and that's what was really puzzling me. But in any case, Chavi beta, is that okay? Why we have this graph? Yes, Petaji? Or have I confused you guys?
No, yes, sir, I got it. I was just doing, yes, sir, I got it.
Okay. We're running out of time. I think it's 6:30. So let's stop it here. We'll resume from this point onwards. I'm gonna share this link. If you get a chance, go through this. So let me just kind of roll through this particular block, see what do we have. So once we have gone through relative position, we'll talk about relative velocity. First we'll talk about relative velocity in one dimension, and we'll solve few simple problems. Then we'll look at time to meet or collide in one dimension, right? So for two particles, how much time will it take for them to collide or meet when both of them are moving along one dimension? And then we'll get into the two-dimensional motion, right? So we'll start with the Riemann problem. So relative velocity in the two dimensions, right? Riemann problem is essentially the man is walking at a certain velocity, and obviously the rain, which is another particle. So think of man as a particle, rain as a particle. So one particle is moving with a certain velocity, let's say in the horizontal direction. Another is moving in kind of either vertical or some direction, either at some angle with the vertical or purely vertical, whatever it might be. Now, when you try and think about the relative velocity with respect, the relative velocity of rain with respect to the man, then we will see how do we do that, right? So again, same relationship will apply, VA minus VB, okay? So they will learn to use vector algebra to figure that piece out. And then we'll test ourselves with some interesting problems. So I think this is a fairly good problem. So we'll do that. And then we will jump into swimmer and river. And for that, we'll go back to our question types there. And then we're going to look at some other scenarios involving a particle projected from a moving platform. Particle projected from a moving platform. Okay, and that should be enough for us to start feeling comfortable about the relative motion. And this is the last one that we'll do, which is the what I kind of initially spoke about. So typically till this stage you have always looked at scenarios, especially one-dimensional motion. If two trains are approaching each other, when will they collide, right? How much distance? Yeah, if they're moving in the same direction, long before one passes the other one, right? So we have done those kind of problems. Here we're going to look at a scenario where the two particles are moving in the two dimensions, and obviously they don't need to meet necessarily. They don't need to meet up. So if they don't meet up, if they don't collide, then what is the closest they get to each other, right? What is the minimum distance between the two? We'll learn how to do that using vector algebra. This one will be pretty interesting. So difficulty level, this one is definitely a higher difficulty level.
Sir?
Yes, Peter.
So those elevator problems also come in relative motion, right?
The elevator problem, yes, Peter, they will be in the one-dimensional relative motion. Relative motion.
So I have a few questions. I don't have them handy with me right now, which I was struggling with in terms of elevator ones. So can we either solve them next class, like one or two of them, and or like can I just send it to you and can you just help me out with them?
Yeah, Peter, you can share them in the class. You can bring them in the class. No problem, Peter.
Yes, yes, sir.
Okay, but we will go through all these things systematically. There's a lot to learn, but this is important beta. So anyway, so we'll stop the class here. I'll catch up with you guys. Okay, we'll try and start at 5 p.m. sharp. Thank you so much.
Yes, so also so sorry for coming late today. I just slept. I didn't know. I completely forgot.
Understandable, beta. Understandable. Okay, don't feel bad about it. It happens. It happens to all. Okay.
Yes, sir.
Take care, beta. Take care. I'll see you tomorrow.
Thank you, sir.
Thank
Bye,
you,
beta.
sir.
Bye-bye.